we've got a body of mass 4 kgs resting on a plane which is inclined at an angle of 30 degrees to the horizontal, and it is just prevented from moving by friction, so it is in equilibrium. What is its weight? All right, so a bit more space, let's go. The weight of this guy, well, it's 4 kgs, and we've got normal acceleration due to gravity. So weight is equal to m times g, which is 4 times 9.8. So its weight is 39.2 newtons. Part B. What is the magnitude of the normal reaction? Right, so the normal reaction, which is acting in the direction of the j vector, is going to have to be equal to the component of the weight, which is parallel to the j vector. So if I just zoom in here a little bit so we can see exactly what's going on, we need to resolve w into i's and j's. So here is the j part of vector w, here is the I part. Okay, so I need this side here. Just went away. There we go. Need that side there. And whatever that is the magnitude of the n vector. So given that we've got 30 degrees as our incline, that means that this angle up here is also 30 degrees. Using 30 degrees in there, we need the adjacent side and the hypotenuse, because we know that. So we're going to use cos to figure out that side, along with the magnitude of w. So if I want the magnitude of n, I need the amount of the w vector which runs vertically, let's say, or parallel to the j vector. That is going to equal 39.2 cos 30 degrees, which is 33.9 newtons. Very good. Part C, the magnitude of the frictional force. So the frictional force in pink over there needs to balance out the component of the weight force, which runs parallel to the slope, or the I vector. So now we need to address F as it equals the x component, or horizontal component, of the weight vector. This will be 39.2 sine 30 degrees. And I believe that's 19.6, just keeping it to one decimal place, in newtons. All right. Now that will technically be negative because it's going in a negative direction, but they're after the magnitude, so we'll just stick it there. Part D, last thing, the coefficient of friction. So the coefficient of friction, remember that our rule here is coefficient times by normal, and our friction force is 19.6. Our coefficient of friction in there, multiply that by the normal, which is 33.9. We rearrange to solve that, and our coefficient of friction this time is 0.58. When we divide both sides by 33.9. Done.